All right, let's talk about one of nature's most incredible shows. We've all seen lightning tear across the sky, but what is actually going on up there? Let's dive in and figure it out.
I mean, it is just raw, untamed power, right? A single bolt of lightning can be 5 times hotter than the surface of the sun. It can carry enough juice to power your house for a month. So the question is, how does a cloud, something that looks like a puff of cotton, create that much energy? Well, the answer is actually something you probably played with before.
You know, when you rub a balloon on your hair and it sticks, it's that. Seriously. The whole secret behind this massive, sky-splitting event is just static electricity, but on a scale that is almost impossible to imagine. So how do we get from a party trick to a thunderstorm?
Okay, so to get to the big flash, we've got to start small. We need to go inside the storm cloud itself. This is ground zero. It's where a simple cloud transforms into a gigantic battery hanging in the sky.
The whole process kicks off with something called charge separation. This is the absolute key. Think of it as the engine of the storm. It's the mechanism that sorts all the electrical charges and really sets the stage for what's about to happen.
So picture the inside of a big thundercloud. It is not a calm, fluffy place up there. It is a chaotic mess of violent winds, updrafts and downdrafts just churning everything around. And inside this chaos, you've got millions of tiny ice particles and little water droplets all smashing into each other over and over again.
And every single one of those little collisions is like a tiny transaction. An electron gets knocked off one particle and sticks to another. What happens is the lighter ice crystals end up with a positive charge, and they get whisked up to the top of the cloud by those updrafts. Meanwhile, the heavier water droplets grab those extra electrons, become negatively charged, and sink down toward the bottom.
So what's the upshot of all this chaos? After millions and millions of these collisions, the cloud gets polarized. You end up with this huge positive charge way up at the top, and a massive, powerful negative charge building up at the bottom. The storm cloud has officially become a giant battery in the sky, just waiting for the right moment to discharge.
All right, so our battery is fully charged up there in the sky. Now we get to the main event, the flash itself. Let's break down exactly what happens in that split second when it looks like the sky is ripping open.
So what our eyes see as one single flash is actually a super fast 4-step process. First, that negative charge at the bottom of the cloud just gets to be too much. The cloud can't hold it anymore, so it sends down a faint, almost invisible channel of negative energy called a stepped leader, searching for a path to the ground. As it gets close, the ground, which is now positively charged, sends up its own little streamer to meet it. And when those two connect, bam, a circuit is completed. That opens the floodgates for the return stroke, which is this massive surge of current that creates the brilliant flash of lightning we actually see.
And this is the part that blows a lot of people's minds. The bright flash that we call lightning, it's actually traveling up from the ground into the cloud. The stepped leader is kind of like the invisible scout that goes down and finds the path. But the return stroke is the main event, the spectacular, super bright explosion of energy that races up that path.
But wait, we're not done. The light show is just Act 1, right? Because every flash of lightning has its own signature soundtrack. So what exactly is that earth-shaking rumble we call thunder?
You know that thing we all do, right? You see the flash, you start counting. 1,000, 2, 1,000, to see how far away the storm is. But that brings up a really good question. If the lightning and the thunder are made at the exact same time, why don't we see and hear them at the same time?
Well, part 1 of the answer is the speed of light. It is just ridiculously fast. So fast that the light from that bolt hits your eyes pretty much the instant it happens. From our perspective, there's no travel time at all.
But then you've got sound. And sound, well, it kind of takes its sweet time. It's just a physical wave moving through the air, and it's way, way slower. So light wins the race to your senses every single time, and the sound just sort of ambles along behind it. So, what is that sound we're waiting for? That channel of lightning is mind-bogglingly hot, hotter than the sun's surface. In a fraction of a second, it superheats the air around it, causing that air to expand explosively. It creates a literal shockwave. That shockwave is what we hear as thunder.
And that really pulls it all together, doesn't it? It's this incredible chain reaction. You start with tiny collisions, which create a charge. That charge builds up until it has to go somewhere. It creates that brilliant flash, and that flash creates a sonic boom that echoes for miles. It's just a perfect story of physics written across the sky.
So the next time you see a storm rolling in, you'll know the incredible science that's happening behind the scenes. And it kind of leaves you with one last big thought. A single thunderstorm can hold more energy than some entire cities use in a day. Now that we understand how it's made, just imagine, what if we could one day figure out how to capture it? What could we even do with that kind of power?